Hello, I welcome you all to this another interesting screencast. The problem reads, at the instant shown, cars A and B are traveling at the speeds shown. If B is accelerating at 1200 km per hour squared while A maintains a constant speed, determine the velocity and acceleration of A with respect to B. This problem is coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. In this particular problem, we have been asked to determine the velocity and acceleration of A with respect to B. VA stroke B. Writing it as a vector, this is equal to VA minus VB. Okay. VA and VB are absolute velocities. The acceleration also will be, writing it as a vector, it is A, small letter A, and then sub capital letter A stroke B is equal to A minus AB. So A and B, these are absolute velocity and acceleration. Then A stroke B, these are relative, this is relative velocity and relative acceleration. So VA and VB, like we said, these are absolute velocities, and by this we mean they are being observed from a fixed reference frame, while VA stroke B is a relative velocity, and by this we mean is being observed from a translating reference frame. And in our case, the translating reference frame, we are going to denote it as x prime and y prime, and it is at B. Okay, so our translating will be at B. We are going to denote it like so. So this is where we are observing the velocity of A with respect to B, observing it from the translating reference frame. So this is our x prime, this is our y prime. And let's also just place our fixed at this arbitrary point. This is our fixed reference frame, and let's call this as our x and our y. And when we check on these two reference frames, they are parallel to each other. All right. One thing to note is x prime and y prime will translate. There is not going to be any change in direction with time. X prime and y prime translate and no change in direction. And therefore, what we are going to be dealing with are magnitudes for these relative quantities. Okay, their change in their magnitudes. Okay, so what we are going to be dealing with is the change in their magnitudes. All right. Okay. Right. So let's go ahead. For VA, we expect, since VA is experiencing what we are calling curvilinear motion, so we expect for acceleration here, if we are to use the tangential and the normal axis, we are going to expect acceleration, okay, as well, okay, in the towards the center of the curvature, while acceleration tangential to this particular instant will be equal to 0 because our velocity is constant. All right, so let's get some components of our velocity. we are going to have two components like so, and then like I said, we could have had a component there, okay, like so, and the normal component there. These could have been accelerations, of course. Let me just indicate them, and then so this one here, what's the angle? The angle is already been given to us is 45, so we expect one of these, both of these to be 45, so we can choose whichever. Alright, so let's pick this one. It's 45 degrees. So we expect this one is going to be equal to 20 cos 45, and this one is 20 sine 45. Alright, this one is AN, okay, centripetal acceleration. This one is AT, which is just the change of our speed with respect to time. Right, okay, so we know to say our AT here is equal to the change of speed with respect to time, and since the speed is constant, right, that's what they told us, right? They said air maintains a constant speed, therefore this acceleration AT is going to be equal to 0, while AN we know is equal to acceleration squared divided by rho, where rho is the radius of curvature, and this is going to be equal to, what's the speed given? The speed is 20 kilometers per hour, so squared divided by 100. Okay, so what do we get? Let's grab our calculator. So 20 squared divided by 100, this gives us a 4. It gives us, sorry, this I need to convert this kilometer, I mean 100 into kilometers, right? So I'll say that's 100 divided by 1,000. Okay, so 100 meters is equal to 0.1 kilometers. So here I'll put 0.1. Okay, so we have 20 squared divided by 0.1. So this gives us this gives us a 4,000. This gives us a 4,000 kilometers per hour squared. So this is the centripetal acceleration that it will experience. Right, let's start with velocity now. So like we said, our VA, so velocity, start with velocity. Can we create a boundary? Maybe we create a boundary. Right, so we have VA is equal to 65 I. Okay, VB is equal to VB, we have two components, so we have 20 negative, this is negative 20 cos 45 I plus 20 sine 45 j. Right. Therefore, our VA stroke B, which is equal to VA minus VB, if we did the subtraction and addition of vectors, which you can do. So we have VA is 65 minus minus 20, which becomes a plus 20 cos 45. Okay, so this becomes equal to a 79.14 I. Okay, so this one becomes a 79.14 I minus 20 cos 45. I mean sine 40 is the same thing. So this one becomes a 14.14 J. Okay, so there we go, and this one is kilometers per hour. So what do we have? We have VAB X component equal to 79.14 I and then we have VB Y equal to minus 14.14. Okay, so we remove this. Okay, like so. So these are the quantities that we have. Right. Let's find the magnitude. So VAB magnitude, which is equal to VAB magnitude, this is equal to the square root of VAB X squared plus VAB Y squared. Therefore, VAB is equal to that's 79. This one it gave us. Let me just check it again. We check this one again. Sorry, 20 plus 45 plus 65, 79.14. Okay, 79.14 squared plus 14.14 squared. Square root of that. So we get 80. We get 80.39 kilometers per hour. Right, let's find the angle. Okay, theta is equal to tan inverse of VAB Y divided by VAB X. Therefore, theta is going to be equal to VABY, what is it? It's minus 14.14 divided by 79.14. Okay, tan inverse of that, we get a minus 10.13 degrees, which is also equal to just 10.13 degrees, and then instead of indicating a minus, it's just something like so. Okay, this is going down, This is going down like so. Okay, like so. All right. So there we are. We found velocity. Let's go to acceleration. Okay. Right. So for acceleration, let's do the job. For acceleration, we have AA is given as, so we have two components here, in fact, that I forgot to show. So we'll have one in this direction, and another one in that direction, right? And then this is 45, but they are all 45s, right? So this one, let's choose that one. All right. So there we go. We have 45 like so. Okay, maybe it's not okay there. Let's say we pick it there, we say 45 down like so. All right, and then here we're going to have an. We have an cos 45, and then this one we have an sine 45. Okay, so an we only have positive value, which is a 4000 cos 45 I, and then plus a 4000 sine 45 j, right? And then AB, we do have we've been told the acceleration for B is accelerating, so it's in that direction, so it's 1200 I. Therefore, our relative acceleration A stroke B, which is equal to A minus A B. This therefore gives us, let's work out. So we'll have 4000 cos 45 minus 1200. Okay, so this gives us 28.43 I plus 4000 sine 45. So this is a 28.43 J. Okay, so we have a component in the x direction equal to a 1628.43 and a component in the y direction which is 28.43. So let's find the magnitude. Therefore, A stroke B is going to be equal to the magnitude, okay, which is equal to square root of AB x squared plus AB y squared, which gives us a stroke b, and this is equal to 1628.43 squared plus 2828.43 squared. Then square root of that, we get a 3263.71 kilometers per hour squared. Let's find the angle. Okay, this is going to be equal to tan inverse of ABY divided by ABX. Therefore, the angle itself is just going to be equal to, where do we have these values? We have y down there. Okay. So what is our AY? Both of them are positive. Our AY is 28.43 divided by 1628.43, and then tan inverse of that, we get a 60.07 degrees. And this one is a positive one, so we expect something like so, right? These are all positives. So let's show them how they look. We can start with this one. So one is negative, like so, and then the other one is positive, like so. So we have one which is negative in the y, the other one is positive, like so. And then we have the resultant. Which is cause it to be closer to the bigger value according to the principles of addition and subtraction of vectors. Right, in this case both of them are positive, so we'll have something like so, and then something like so. Okay, right, y seems to be larger there, right? So the resultant will be closer to the y value, like so. Let's label them. So this one is our A stroke B. This one is our B, A stroke B. This one is our B, A stroke B, X. And this one is our B, A, B, Y. This one is our A, B, Y. And this one is our A, B, X. Alright, and then we do have the angle here as our theta. That's the reason we had a negative. And then there, that's our theta. That's the reason we had a positive. So let's outline our solutions. We had a vector here for our solution for velocity, relative velocity, which is this one here. Take it a little bit up like so. Alright, so there we go. That is our solution. And then we had this magnitude there like so. Okay. And then we had this direction. Okay. And we've shown this also here down. And then we have this. Let me just move this. I move it maybe somewhere here like so that I can include the units. Let me include the units. I do include the units, so let me put equal sign somewhere there. I do this like so. then I say kilometer per hour squared. This is better, right? I think so, it's better. And then maybe I move this somewhere there. I create a little bit of space. Right. So let me get this again so that I don't cut it somewhere there. Alright. So there we go. We have our acceleration, relative acceleration. There we go. Okay, or being observed from a B. Okay. And then we do have the angle. We have the magnitude of our acceleration. Alright. And we do have the angle there like so. Right. So I think this is about it. And I hope this video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.